Now let's talk about capacitance. Remember, the capacitance, C, is a measure of how much charge or energy a capacitor can store. And the charge on any given capacitor is Q. Now remember, there are two parallel plates. One is plus Q and one is minus Q. So we just say that the charge is Q. And if I apply some voltage across, so that this is 0 volts and this is my maximum volts, then the charge is equal to CV. These are pretty straightforward problems. A capacitor has a capacitance of 1 farad. So what's the potential difference if you have 2 coulombs on charge on one plate? So C is 1 farad, and Q is 3 coulombs. Now this is confusing, I know, because I've got C for symbols, C for units. Just be careful. I know that the charge is equal to the charge on a capacitor is equal to CV. Sorry about that, pin's acting up. So the voltage, I'm going to divide through by C. So the voltage is Q divided by C. The charge is 3 coulombs divided by the capacitance, which is 1 farad, or 3 volts. Now, a capacitor of 1 microfarad, all right, has a potential difference of 2 times 10 to the negative 5 volts. What's the charge? All right, so now my capacitance is 1 microfarad, and you know a microfarad is 10 to the negative 6 farads. And you have a voltage of 2 times 10 to the negative 5th volts. I'm looking for the charge. So I'm looking for Q. So I know Q is CV. I know, I'm swapping between uppercase and lowercase. So this is, the capacitance is 10 to the negative 6 farads times 2.0 times 10 to the negative 5 volts, or 2 times 10 to the negative 11 coulombs. What is a capacitance? If you have 2 volts holding 6 microcoulombs of charge. So the volts is 2 volts. Q is 6 microcoulombs, which you remember is 6 times 10 to the negative 6 coulombs. Well, Q equals CV. I have Q, I have V, I'm looking for C. So I divide both sides through by V. The capacitance is Q divided by V. So this is 6 times 10 to the negative 6 coulombs divided by the voltage of 2 volts, or 3 times 10 to the negative 6 farads.